Just as with the other arithmetic calculations, we won't want to count out steps on the number line forever. Now the number line serves a vital role in helping us to think about the calculations with negatives. Example, compute 5 plus negative 3. We will draw a schematic diagram of this calculation. We move 5 spaces to the right, and then 3 spaces to the left. Your intuition should tell you to stop before you get back to 0 because you've taken more steps to the right than to the left. And the final answer is 2. 5 plus negative 3 equals 2. The importance of the number line here is to help you to determine whether the final answer will be positive or negative. And to get this, you only need to think about whether you move more to the right or to the left. In this case, we move more to the right, and so the final answer will be positive because positive numbers are to the right of 0. Example, compute 4 plus negative 9. Again, we'll sketch out the number line. We move 4 spaces to the right, and then 9 to the left. Once again, your intuition should tell you about this movement. It should tell you that you should end up to the left of 0 because there's more steps to the left than to the right. So the final answer will be negative. When we move 9 steps back to the left, we have to use 4 of those steps just to get back to 0, and that leaves us 5 more steps to the left. That leaves us at negative 5. So the final answer is negative 5. Notice how natural this process is. Many students learn to work with negative signs by learning a bunch of rules. You take the bigger number and subtract the smaller, then take the sign according to which number is bigger. Unfortunately, that approach hides the simplicity of what's being asked. The number line picture draws on some deep physical intuitions to guide the calculation, and bridging this gap is an important step in the development of your mathematical abilities. Example, compute 34 plus negative 23. Students often panic when they deal with two-digit numbers that involve negatives, but it's really not so bad. We just think about the picture. We move 34 steps to the right, and then 23 steps to the left. We have not taken enough steps to get back to 0, so we will end up on the right-hand side of the number line. And now we just do the calculation that we've done many times before. If we go 34 to the right and then 23 to the left, that's the same as going 20 to the left and 3 to the left, which leaves us at 11. So the final answer is 11. Example, compute negative 32 plus 48. Again, the picture. 32 steps to the left, and then 48 steps to the right. We've moved more to the right than to the left, so the final answer will be positive. Positive what? Well, we have to use 32 of the steps to get back to 0, and that leaves us 16 more to finish off the movement. So the final answer is 16. Negative 32 plus 48 equals 16. This takes some practice and just a little bit of patience. With all the arithmetic practice you've had up to this point, this should not seem too difficult. Example, compute 42 plus negative 65. This time we won't draw the picture. Just think about the process in your head. 42 steps to the right and 65 steps to the left. Will the final answer be positive or negative? Since we've moved more to the left than to the right, the final answer will be negative. Negative what? Well, we have to use up 42 of the steps to get back to 0. And with a quick calculation, you should see that leaves you with 23 steps to go. So the final answer is negative 23. 42 plus negative 65 is negative 23. When doing these calculations, you should always think through the problem completely. Very often, students lose points because they forget to answer the question of whether the final answer will be positive or negative. By keeping a picture of the number line in your head, you're more likely to remember to write down everything you need to write.